Welcome to all. In this fluid mechanics, today we are going to discuss about the Pelton turbine. So it is one of the very important hydraulic turbine, which is used for producing electricity, especially in hydropower plant, hydroelectric power plant, right? The turbine is playing major role. So in hydroelectric power plant, we are using hydraulic turbines. So one of the very important and first and foremost turbine is Pelton turbine. The components of Pelton turbines are given in this picture. Penstock pipe. So this penstock pipe is connected to a dam. So before this penstock pipe, there is a reservoir or dam, right? So from the reservoir, so we are supplying the water, right? So water is supplied through penstock pipe. So after crossing the penstock pipe, the water is entering to the turbine portion. So through a nozzle. So not this is nozzle. So this now work of this nozzle is to increase the velocity of water. So the water is coming out like a jet, water jet. We are calling this blue color shaded area is water jet. Right in the above blue color shaded area is water jet. So this water jet will strike on the blades, right? So once the water jet is strike on the plate, the blade or the buckets, we are calling this as buckets, which is provided or which is fitted over the runner. Runner is a circular plate, right? So once the bucket meets the water, right? Jet of water means high velocity water. So the runner portion gets rotates, right? So when the runner portion is rotates, the center shaft is also rotating. The shaft is connected with the generator, that is dynamo, right? Our cycle dynamo. Same our cycle dynamo principle. Cycle dynamo principle, mechanical energy is converted into electricity. That's why the light is glowing in front of the cycle, right? Okay. So the main component in this turbine, the people who are studying in mechanical engineering, civil engineering, and agriculture engineering. So the main component of this turbine is nothing but runner and buckets, right? So we have to discuss or we have to focus on this because the common area is supplying water. The components which are used for supplying water from the reservoir to turbine is common, and the specific component is runner and buckets, right? Let us discuss about that within 1 or 2 minutes. Yes, Pelton turbine is looking especially the runner, right? Runner is looking like this. The bucket is very, very important. You just look at this black color buckets, right? The shape of the bucket is actually, yeah, just come. This one is runner, yes, as I told you, runner with the buckets, right? Here it is kept as a horizontal position, right? So once you supply the water on the bucket, the runner gets rotates, right? The shape of the runner is the shape of the bucket is looking like this. If you look at the right side picture, right? So the bucket is a splitter ridge. That means it is two half section, right? It is splitted into two halves, not a single bucket, right? So there is a line at the center that is called splitter ridge, right? So this is nothing but a splitter ridge. If you look at the that splitted line is splitter ridge in this picture, left side picture, right? And next one is a nostrils of cow nose, right? So here there is a slot. It is looking like a nozzle of cow nose, right? There is two holes in the nozzle of cows, right? So that is that shape, whatever the shape is having the nose in the cow, right? Nostrils of cow's nose. The same shape is we have given. That means Pelton. Pelton is a inventor of this Pelton turbine, right? Pelton is Pelton. He is the inventor of Pelton turbine. He is modeled. He is designed bucket like this. This design is very, very important. Splitter ridge and nostrils of cow nose, right? So like this, he has modeled, designed, and manufactured the buckets, and he fitted over the number of buckets fitted over the runner, right? Yes. Next one. And here there is a mathematical concepts also included here: diameter, x and y, and theta's angles, right? And inside, outside of the buckets. Inside buckets we have already discussed. There is a split ridge at the middle, and the nostrils of cow nose at the edges, right? Outermost part is looking like a cutout portion. That cutout portion is used for consuming more water, whatever the water coming out from the nozzle, right? If the amount of, say for example, x amount of coming out from the nozzle, that almost 95% of 95% of x will be consumed, right, by the bucket. That's why the shape is modeled like nostrils of cow nose and split ridge like this. Why he has included means we have to extract all the hydraulic energy from the jet of water. That's why they have Pelton have designed like this. Yes, this is the final one. The inner shape and outer shape of the bucket will be consume maximum amount of momentum from the jet. Momentum means nothing but mass into velocity, right? Whatever the mass coming out from the nozzle, whatever the velocity, right? Whatever the speed and mass. Speed is nothing but velocity of water, right? So per second, how much distance it has been covered. That is your velocity of water, right? So that will be consumed maximum by this shape, right? That will be whatever the amount of water coming out from the nozzle and also velocity will be consumed by the bucket. That's why we are our Pelton has adopted the shapes split ridge and nostrils of cow nose, and also cutout part, outer part of the bucket. So this is very, very important. Thank you. Please like our video and share it to your friends and subscribe our channel. So we'll post this kind of fluid mechanics videos in future again and again. So it will be useful, I think. So if you have any comments on this Pelton turbine, please forward it to me. Thank you.